this video, we're going to actually look at one of your homework questions, which is number 28, has to do with the population model. So what I have is the following population model where the population's in millions of people, and T is in years, but T is zeros looking at 2010. So if we wanted to look at 2020, we would plug in T as 10, assuming this model still works. Okay, the first thing is that you can always graph this in Desmos, and if you graph it in Desmos, what you're going to find out is that it has a vertex at negative 1.8, 6.6. So what that is saying is that back over here is where it's decreasing. At negative 1.8, it's now going to be coming back up like this. Okay. The reason why I'm saying that is because since we are assuming that we're starting at T as 0, we actually only care about this portion of the graph. And they didn't tell us how long it's good for. So I don't know if it's good till 2016 or 2020. By the way, they may have told us. I just don't have my book open right now. So right now we're saying, look, we're going to start here at T as 0. This is always increasing. What do I mean by increasing? Walk on it from left to right. If I walk on this from left to right, I'm going up. Okay, so what that's telling us is that the population of this city is going up. All right, now, if I want to know the growth rate, we would take a derivative. So if I take this function and take the derivative, I want to take 0.0078 times 2, which is 0.0156. And then the derivative of the next piece will just be 0.028. All right, now what this is going to do is this is going to tell me the number of people per year that are growing in the city. Okay, now growth rate, by the way, it's not just births and deaths. It's also people moving in and out of the city. Okay, now if I were to graph this function is also always increasing. So what that's telling us is that because it's always positive, always increasing, the growth rate is always going up for the city. It's not leveling it off. It's not stopping. Now, how do I know this? Graph this. This is just a line. Y equals this equation is just going to be a line. That line's going to have this slope, right? So it's just going to be this flattish line, depending on how you have it set up in Desmos. But I'm always going up, steadily going up. Okay, so if you want to know what is the growth rate in, let's say, 2015, 2015 would be plug in 5. If you wanted to know what it was in 2020, assuming that this model works for then, I would plug in 10. Okay, so since I have my calculator here, I'll go ahead and do this quick calculation. And what I get is the very lovely 0.106. You're like, it's a fraction of a person? No, this is millions of people per year. So if you want it in a number that's a little bit nicer, just take this decimal and times it by 1,000,000. I need 6 zeros. So if I do this, what we're finding out is that this city is actually getting 106,000 people per year. All right. So as they ask questions in the book about what do you notice about the growth rate or what do you notice about the original function, it pretty much is going to Desmos and looking to see if it's always increasing. Now here, again, in the original function, it's always increasing on the interval that I'm looking at it. But if I was looking at it on this side, I would say it's decreasing till this moment and then increasing. It just so happens that this is not in the part of the picture I want to look at. All right, don't forget to use Desmos on some of those problems. It will help a lot. Good luck. I hope your homework goes well.